Hello, everyone. My topic today is quantum manifestation of information. It's short for quantum observing manifestation of information. Nowadays, we are still talking about information in different meanings, quite different. I think it's reasonable because we need different definitions of information when we deal with information within different research areas. But with the development of information technology, all the related areas are integrating. So we need some kind of definition of information that can suitable for all research areas. So we need a deeper understanding of information. As a matter of fact, the development of quantum mechanics gave us a great opportunity to get a better understanding of information. But it's impossible to notice it until we develop the development of information technology, especially big data and artificial intelligence. So it means we should go back to quantum mechanics and get some answers from the opportunity. Here is some of my ideas. First of all, in my mind, information is a relative relation. It's a kind of transform from entity to relation. Secondly, I think information or quantum information is not information of a different kind. Usually we think quantum information is a very special information because it's hard to understand. But I think quantum information is also the same information, but the signals or the interaction in there is different. Let's see the situation of quantum observation. When we say quantum phenomenon, we think it's something produced in the process of observing. There is no observing. There is no quantum phenomenon. So quantum phenomenon itself is the typical information as a receptive relation. Niels Bohr once said, we need redefining quantum phenomena. I think all the phenomena is the same. If we talk it, understand it in the information dimension. My third point of view is the so-called intrinsic randomness is not a natural character of things, but a described one by agents, by human beings. In this way, we can understand information quantum mechanics in this way. Today, we talk about information quantum mechanics refers to studies on quantum physics and has little to do with understanding information itself. Yet starting from the view of information is indeed a key for deepening our understanding of quantum physics. According to the situation, of quantum observation, we think we can say something like this: the moon doesn't exist when you are not looking at it. So we can see the moon here, but it's out there no matter you are seeing a lot. Just like the sea, the houses, and even my eyes. If my eyes don't exist, how can I see the moon? So it seems another kind of statement like, I think, therefore I am. I say, put it in English way, I see, therefore my eyes exist. But what's the difference between the two statements? All we can say is that all quantum phenomena are the result of observation. So seeing is more basic than thinking. There's no time for me to further going to this subject, but I think here is a very important point. We cannot say, or we hardly can say, the moon is not there when you're not looking at it. But if we mention some daily experience, we can see it's an easily understanding example. And actually, the green of the leaves is generated by observation, by our looking. So is the red of the flower. I think it's a very simple and a daily example. Just like John Locke said, the second nature. But according to John Locke, the first nature is also the same nature, I think. So we can go deeper into quantum mechanics, especially quantum paradox. So we can get some conclusions before that. Firstly, since human cannot directly perceive microscopic objects, human as advanced receiver cannot avoid self-involvement in the same macro scale. So with the picture of matter or energy plus that of information gradually comes into focus. Quantum information itself is typical receptive relation. Secondly, I think the information understanding of quantum mechanics is closely related to the special informational correlations of quantum mechanics. And if we carry it through, we may even reach an informational quantum theory in its true meaning, true sense. Finally, I think the presentation of information in quantum mechanics plays a totally different role from that of the presentation in big data, as our understanding of information develops. As a matter of fact, it's also in artificial intelligence. You can see this kind of same picture. But quantum mechanics has a unique advantage in information understanding and studies. That is, the empirical scientific correlations of information. Let's see it through the quantum paradox. Usually we say Chinese cat, sorry, it's rather like Chinese tiger. Chinese cat is either alive or dead, or neither alive or dead, until we open the box. It is in a quantum superposition state. That's our explanation. But we still got a problem. What's really going on in the dark box? As a matter of fact, we can say more in this way. The wave packet collapsed when we open the box and observe it. That is a kind of statistical description, and it is a mathematical one. It's not our picture about entity. So what's going on in the box? Let's imagine that it's a glass box. We need not open it. Then we can see there is no such kind of thing as wave packet collapsed in reality. Wave packet collapsed is very important in description, but it doesn't give us a whole picture of the physical world. So to see means in this situation, means to build some kind of receptive relation. That is information itself. Let's talk about the cat, another cat, the cashier cat, the quantum cashier cat. The cat is a photon. It is in one place, and it's green. That refers to the circular polarization. It is in another place, so it's separated. That is a problem. That is one of the paradoxical phenomena of quantum mechanics. That is, and I think a very important situation for us to understand the information. I think which this paradox actually is a revelation of information, because we can get different kinds of interpretation about it. One of them is a material interpretation. It says any quantum entity can be disembodied from its physical attributes. So this brain is a big problem. Another interpretation is an informational interpretation. It says in this way, any quantum physical attribute can be disembodied from its entity, and is reasonable because we can see it or explain it in this way. Some of the stars we see now were actually eliminated light years ago, but we can still see it. So it means the exact situation is that certain receiver builds up with the signal from the annihilated star. So it have been missing a lot from the presentation of information by quantum mechanics. Thank you very much.